on to lesson 1A6, Composite Functions, and this is interesting and actually kind of fun at a lot of times because we're just putting one function inside of another or multiple functions. There's no limit on this. So let's make sure we got the notation right, and you've probably seen this before. F of g of x can be written as this right here. Let me get my pen going. Or I can write it like this, and I do both interchangeably without much thought, and so can you. So let's take a look at three quick examples. We have f of g of x, so we're going to have f of g of x. So this is g of x. I'm going to put x squared right here. And that's nothing more than wherever I see an x, I put in an x squared. So that's just going to be 2x squared plus 3. Can't get much easier than that. So let's take a look at the next one. So we're going to do g of f of x. Well, the f of x goes right here. F of x is 2x plus 3. So in goes 2x plus 3 right here. So we're going to have 2x plus 3 squared. And I can do the binomial multiplication of that. That's just going to be 4x squared. And if I don't say you have to simplify, it's a good practice too. And then 3 times 2 is 6, double that. That's going to be 12. This is a perfect square trinomial. And of course, plus 9. All right. Here we have f of x. So we're just throwing f of x back in. So we're going to do f of x. Well, f of x is 2x plus 3. So in goes at 2x plus 3. So wherever we see an x, we put in 2x plus 3. So 2 times 2x plus 3 plus 3. Distribute, that's going to be 4x plus 6 plus 3. And so we have 4x plus 9. All right, moving on. So what we're going to do is we're going to ask a little bit more complex things. We're going to ask you to find the domain of each function and the resulting the composite. So here we have two functions. F of x is 1 over x squared, and g of x is just x plus 3, a nice, good, easy linear. And just real quick, I want to go off in the corner here and show you the graph of f of x. So f of x, the graph of that, and this is going to be a terrible sketch on this little writing pad I have. And if you remember your parent function, it's just nothing more than coming down here. And as x gets really small, y gets really close to 0. And as x gets really big, x also gets really close to 0. Of course, it's just reflected over the y-axis. All right, and g of x, I could sketch that in green, is just a real simple linear. All right, it's just x plus 3. It's your parent function translated up 3, so it's just going to look something like that, okay? And we're going to put this function inside of that one. Well, what's going on here? Well, take a look. When we put this x plus 3, so we would do f of g of x goes in right here, g of x. That's just x plus 3, so that's going to be x plus 3. So this is going to be 1 over x plus 3 squared. I can do the binomial multiplication or expansion of this and do a t-chart, but let's start practicing some of our algebra skills. This is nothing more than this parent function translated left 3. So I could go back down to my graph. I'll do a little quick graph. Here's x and y, okay? And I'll do this in purple. I'm going to translate this left 3. So instead of x equals 0, I'm going to have x is equal to negative 3. I had to have sound effects. Negative 3. And it's going to be this function right here. So down it comes, and it gets really close to 0, but not crossing it. And this gets really close to 0, but not crossing it. Then we're going to write the domain. So the domain, okay, in interval notation, is simply all these x's and all these x's, excluding, and I can do this in set notation if I wanted to, excluding negative 3. So it's going to be negative infinity to negative 3, not inclusive, and from negative 3 to positive infinity. All right? So that's pretty straightforward. We're going to have the same mentality for this one. I'll do this one in green. We're going to do g of f of x. So we're going to do g of f of x. So in goes f of x right here. Well, f of x is just 1 over x squared. So wherever I see an x, I put in 1 over x squared. So here we have g of f of x is equal to 1 over x squared plus 3. This is this parent function translated up 3. So when I go to graph this puppy, I'm going to go down here. There's my x and y graph. And I'm going to take this and move it up 3. So I'll go ahead and do my y is equal to 3 little dash line right here. Y is equal to 3. And as x comes down and gets bigger toward the negative infinity side, it gets very close to y is equal to 3. And then it's going to come down right down here because we still have our asymptote. And it's going to get very close to to y is equal to 3 here as well. Okay, so the domain is simply negative infinity to let's see, 0, yeah, and it's going to be the same domain as the original, and 0 to infinity. Nothing really too exciting. That's the domain. The range, of course, will be restricted to y greater than 3. Alrighty. So I think we got one more topic of this. Let's take a look and break these composite functions apart. So now we have h of x, and I want to write two functions. I want to write a f of g of x. All right? So f will be the outside, g will be the inside, and so on. So there's a couple ways to skin this cat, as we say in East Texas. Don't skin a cat. That wouldn't be polite. So that would be the square root function, and this almost looks like a difference of cubes, but not quite a perfect cube right there. Still can do it, but the other thing I'm going to do is I'm just going to go ahead and call this f of x is equal to the square root of x, and that leaves g of x, the inside part, is equal to x cubed minus 4. So h of x is equal to f of g of x, where this is the outside and that's the inside. Pretty straightforward. Now, let's take a look at this puppy. So what we have here is I'm going to go ahead and factor out a 2. So I have h of x is equal to 2 times x squared plus 10x plus 25. And I see a perfect square trinomial, easy factorable. What times what is 25 now together? That's just going to be x plus 5 squared. So that's equal to 2 times x plus 5 squared. If I were to call this x and call this x squared basically, I can have f of x is equal to 2x squared. That means g of x will equal to x plus 5. All right? So again, when I do h of x is going to equal to f of x of g of x. All right? So that's pretty much it for this one, and I'll get this posted to YouTube.